Yes, this is where we stop in the first part of this video. So this is the second part of this video. So we have discussed how control how microprocessor can control automatic cooker and ovens. We have also discussed how microprocessor can control central heating system. So now we are on greenhouse environmental control. Greenhouse environmental control. Greenhouses are used to control the environmental in order to grow vegetables. In order to grow vegetables, fruits, and flowers in country that they wouldn't normally uh, grow. So this greenhouse environmental control is in the best position uh, to help here. So there are 5 main sensors that tend to be used in a greenhouse. Now, what are the 5 sensors? The first one is humidity. The second one is moisture. The third one is temperature. The fourth one is pH sensor. And the fifth one is light sensor. Humidity sensor, moisture sensor, temperature sensor, pH sensor, and light sensor. Now, what do you understand by humidity sensor? A humidity sensor is a device used to measure or report both moisture and air temperature. Both moisture and what? And air temperature. And we all know what is called moisture. Moisture is what? Is the water content. The water content. To know the level of what? Of water, maybe in a soil. So now let's move on. Now the next one is what? Moisture sensor. You know, I've talked about moisture the other time. So the moisture sensor is used to measure the volume or the content of water. The content of water in a soil. You know, we have what is called, so another example of moisture sensor is soil moisture sensor. So the soil moisture sensor is used to measure the volumetric water content of soil. Water content of soil. Now the next one is temperature. We all know what is called temperature. Temperature sensor, we know the function of temperature sensor is to measure the level of what? Of temperature, to know whether the temperature is low or not. So now the next one is what? pH sensor. pH sensor is one of the most essential tools. That is typically used for water measurement. This type of sensor is able to measure the amount of alkalinity and acidity in water. Is to measure the amount of what? Of alkaline and acid in water. So now the light sensor, we all know the function of this light sensor is to determine the ventilation of a particular place, to know or to determine the darkness and light of a particular place. So now let's move on. So the computer control the environment by taking input from the sensors. That is number one. Number two, sensor readings are converted from analog to digital using an ADC, which I have explained before now, that data must be converted from analog to digital because our computer did not understand analog data or analog signal. Before computer can understand it, it must be converted to digital. Now, microprocessor then compares the sensor reading with the preset value. So you can see the diagram of what? Of greenhouse. You can see plants there. You can see plants. You can see the arrangement of the plant. So now, in this diagram, all what I have explained here is applicable here. Don't forget that greenhouses are used to control the environment in order to grow vegetables, fruit, and flowers. Now let's continue to the next slide. So now this slide is all about how microprocessor can control greenhouse environmental control using all the listed sensors to read the data. The first one is what? Humidity. When humidity or if humidity is greater than preset value, computer sends signal to open windows. Don't forget that humidity measures the what? Measures the moisture and what? And air temperature. So if humidity here is greater than the preset value, computer sends signal to open windows. Now the next one is what? If humidity is lower than preset value, computer send a signal to close window. So it's just like what? Vice versa, or in opposite. The moisture now, if moisture is greater than preset value, computer sends signal to turn on heater to dry. So it means here now there is a lot of what? Water here. There's a lot of water here. So the water is too much here because the moisture is what? Is greater than the preset value. So we need what? We need the heater to dry the water a bit. Now, if moisture is lower than preset value, computer send a signal to open valve to add water. It means that here there's no enough water. Because the moisture is lower than the preset value. That is, the amount of water that's supposed to be here is lower. So we need more water here. So temperature, under temperature. Now, if temperature is greater than preset value, computer sends signal to motor to open window. So if the temperature is too high, automatically there will be heat there. So the moment the microprocessor sense that there is a lot of heat there, then the computer will now send signal to motor to open window. This motor here is for open and close. Is a device that normally open and close the window. So if temperature is lower than preset value, computer send a signal to motor to close window. Now let's quickly move to pH. If pH is greater than preset value, computer sends signal to open valve to add acid. Don't forget that a pH sensor measured the acidity and alkalinity of what? Of the acidity and alkalinity in water. That is the function of a pH sensor. That is the work of what? pH sensor. So let's quickly move to light. If light is greater than preset value, computer sends signal to motor to close blind. Then if light is lower than preset value, computer send a signal to motor to open blind. So at this stage now, the microprocessor continuously monitor the temperature. I hope you are getting my message here. Yes. So now let's quickly move to the next slide. Let's quickly move to the next slide. So this one is all about a chemical process control. Chemical process control involves using a microprocessor to control the condition of producing chemicals, medicine and food. So let's say, for example, that the temperature required for a process to work should be 85 degrees and the acidity should be less than 3.5. So the microprocessor control the process by the following step. The first one, using a temperature and pH sensor to read data from the chemical process. So here temperature sensor and HP sensor is to read the data from chemical process. Now, data from sensor is converted from analog to digital using an ADC, which is analog digital converter, which I have explained before now. The microprocessor compare the sensor reading with preset values. So we have about 4 conditions here. If the temperature is less than 85 degrees, don't forget that our preset value here is exact 84 degrees. Then if the temperature is less than 85 degrees, sorry. So if the temperature is less than 85 degrees, is turn heating on. Don't forget, less than 85 degrees is turn what? Heating on, because it has not attained or reached the preset value, which is 85 degrees. Now the second condition, if temperature is 85 degrees or more, is turn heating off. So now this is the preset value. So if it is equal to 85 degree and greater than 85 degree, definitely the heating will be what? Will be off. Now if pH is greater than 3.5, don't forget that the pH given here, the preset value given here for acidity, which is pH, is 3.5. So if pH is greater than 3.5, microprocessor send a message or a signal to open a valve and add acid. So it means that acid is not enough here. So the amount of acid here is not enough. You can see then if pH is is greater than 3.5. So the next condition, if pH is less than or equal to 3.5, microprocessor send a message to close valve. So it means they have enough acid. That is 3.5 here. 3.5 if pH is less than or equal to 3.5. So if it is less than or equal to 3.5, is still acceptable here. So it means that microprocessor will now send a message to close valve. So at this junction now, microprocessor continuously monitor the temperature. So we have come to the end of today's lesson. Thank you, and God bless you. Please don't forget to stay safe.